Welcome to the Deep Dive, the show where we tear through your stacks of sources and extract the knowledge you need to be well-informed fast. Today, we are plunging into a creature that is so extreme, so shocking in its appearance, it feels less like an animal and more like, well, something out of a sci-fi movie. We're talking about the mandrill. Mandrill is sphinx.
It's arguably one of West Central Africa's most visually stunning phenomena, and it's an animal that holds the title for the largest species of monkey on the planet, yet it's so often misidentified.
Absolutely. I mean, when you look at an adult male mandrill, you're seeing a living rainbow. We're talking about a face with these electric blue ridges, a fiery red stripe.
And that's before you even get to the posterior.
Exactly. And yet for decades, we got its identity totally wrong. You know, everyone thinks of Rafiki from The Lion King. He's always called a baboon.
Right.
But those colors, that striking red and blue, that is pure mandrill, a creature of just extreme size and color that has baffled scientists for years.
It's a species that really demands a closer look, because that whole external appearance is basically a window into a truly unique, hyper-competitive social life.
And that's our mission for today's deep dive. We're going to try and understand three things. First, why on earth was it mistaken for a baboon for so long? Second, how does it achieve those shocking dynamic colors? I mean, how does it pull off the bluest blue in the entire mammal kingdom? And third, how its enormous supergroup social life is actually what's driving all of this extreme evolution.
To set the stage a little, you need to picture the tropical rainforests of West Central Africa. That's its home Gabon, Cameroon, places like that. And despite being the heaviest, strongest Old World monkey, the IUCN Red List classifies the mandrill as vulnerable.
So its existence is actually much more precarious than its appearance would suggest. Okay, so let's unpack this evolutionary puzzle first. For generations, naturalists just couldn't quite place the mandrill. They called it the rib-nosed baboon, the tufted ape.
Even the great baboon.
Yeah, and the name just stuck. So why did early scientists keep lumping it in with the baboons?
Well, to be fair, it was a very reasonable assumption based on what they could see. Mandrills share some really striking, superficial similarities with baboons.
Like what specifically?
They're big, they show extreme sexual dimorphism. The males are huge compared to females, and they're largely terrestrial. They spend most of their day on the ground foraging. That's classic baboon behavior.
So if it walks like a baboon and it's built like a baboon,
why shouldn't it be a baboon? Right. But this is where evolution gets tricky. Modern science genetics, sophisticated skeletal analysis, has shown that these similarities are actually the result of convergent evolution.
Oh, okay.
Things like that long facial structure, the prognathism, it's there to accommodate huge canines. So you have two distinct species that evolve similar body plans because they face similar pressures. They look alike because they're doing similar jobs, not because they're close relatives.
So we can definitively rule out the baboon. What's the mandrill's real family tree then?
The deep dive into mitochondrial DNA was really the key. The genus Mandrillus, which is both the mandrill and its closest relative, the drill. It's genetically closest to the white-eyelid mangabes.
Mangabes, okay, not baboons.
Not baboons, specifically the Circocebus genus. And the split between the mandrill lineage and the mangabes happened, relatively recently in evolutionary terms, about 4.5 million years ago.
And how does that compare to the split with the baboons?
Oh, that's much, much older. The split from the true baboon lineage, Papio, was around 11.5 million years ago, so that's 7 million year difference. It's just this enormous evolutionary gap.
Calling it a baboon is basically ignoring an entire era of primate history.
Exactly. It's on a completely different branch.
And to really drive home that difference, we have to talk about its size. The sexual dimorphism you mentioned is, well, it's off the charts.
The size difference is just an immediate visual cue that the species operates under intense male-on-male competition. Females are big, don't get me wrong, maybe 11 to 15 kilograms. But the adult male, he's a giant. They average between 25 and 35 kilograms, but the largest ones, they can push over 50 kilograms.
50 kilograms. So the male can be 3 times the weight of the female. He's the undisputed heavyweight champion of the monkey world.
And he's got the weaponry to match. That elongated face isn't just for show. A male's canines can reach 4.5 centimeters long.
Almost 2 inches.
Almost 2 full inches. And you compare that to the females, which are about 1 centimeter. That physical difference is a very clear biological advertisement that this animal has to fight, or at least threaten to fight, to succeed socially. And this is where it gets really, really interesting. The mandrill's color palette. The male mandrill is simply one of the most vividly colored mammals on the entire planet.
Right.
And that color is so much more than decoration. It's a complex, high-stakes biological status symbol.
The description alone is almost unbelievable. You have this hairless, ridged face, a bright red stripe running down the nose and lips, and it's flanked by this swollen, intensely blue skin.
And then, of course, the rainbow rump. It's this whole chaotic masterpiece of red, pink, blue, scarlet, purple. The nickname is definitely well-earned.
It is.
Yeah.
So where does that color come from? Especially that blue.
Well, the reds and yellows in the animal kingdom often come from pigments, like carotenes from their diet. But the most fascinating part is that electric blue. The blue skin is one of the very rare instances of structural color in a mammal.
Sweet, it's not caused by a pigment at all.
Not at all.
So I couldn't, extract the blue and paint with it. It's literally about how light is hitting the skin. That's the big aha moment right there.
That's exactly it. Think of it like the iridescent colors on a CD or a soap bubble. The color is produced by the incredibly regular, precise arrangement of collagen fibers in the skin.
Like tiny crystals.
Exactly like tiny crystals. When light hits these microscopic structures, that specific arrangement causes blue light to scatter back at you. It's a process called Bragg scattering. If those fibers were arranged even slightly differently, the color would just disappear or change completely.
So the mandrill has basically evolved a biological light diffraction system on its face. It's built right into its skin.
It is. But that brings us to the second, equally important part of the color equation, its volatility. While the structural blue is fairly stable, the intensity of the redness, the nose stripe, the lips, the genitals, that's intensely dynamic.
And what controls the red?
In a word, testosterone. The saturation of the red is directly fueled by high levels of testosterone. The dominant alpha males, researchers sometimes call them fatted males because of fat deposits on their rumps, have the most blindingly bright colors.
So the redder the face, the higher the status.
The higher the status and the fiercer the fighting fitness. The blue is the ID card, but the red is the real-time status update.
Which is just fascinating. So what happens if an alpha male loses a fight?
That's where the system gets incredible. When he loses his status, his testosterone levels plummet. And when they do, his bright colors will literally fade. The dramatic physical transformation can sometimes partially reverse.
You're saying the color is a survival mechanism to avoid a fight.
It is. It's visual diplomacy. In that gloomy, dense rainforest, rivals don't need to engage in a potentially fatal brawl. They can assess another male's dominance and fitness from a distance just by looking at the saturation of his colors. That red face communicates everything they need to know.
And they can settle things with just posturing, staring, head bobbing.
Ground slapping, exactly. It avoids full-scale combat. The mandrill is basically compelled to be this colorful to survive in such an extreme social system.
So this highly decorated, massive, colorful male, what kind of group does he get to lead? You mentioned this extreme social system.
He gets to lead one of the most astonishing social structures in the primate world. Researchers call it the supergroup, or more commonly, the horde.
The horde. That sounds epic.
It's a fitting term because of the sheer scale. Baboon groups might max out in the low hundreds. But mandrills, they create these massive multi-male, multi-female groups that are almost unprecedented.
How big are we talking?
The average group size is somewhere around 600 to 800 individuals. It's like a mobile, colorful city of monkeys moving through the forest.
That's a number that's just hard to even visualize. A massive community.
And it gets bigger. The absolute record comes from Lope National Park in Gabon. Researchers there documented a single cohesive group of up to 1,300 mandrills.
1,300.
One researcher famously said that trying to count them was like watching a river of highly mobile, multicolored confetti. It is the largest cohesive group of non-human primates ever recorded.
That scale seems like it would be pure chaos. What holds a society that large together, especially when the males are so intensely competitive?
Well, the stability actually comes from the maternal side. Mandrill hordes are often described as female-centric. The females are the stable core of the group.
Okay.
They generally stay in the groups they were born into for their entire lives, which maintains a high degree of social cohesion within that massive structure.
So the foundation is this female kinship network. What about the huge, colorful, high testosterone males? Where do they fit in?
And that's the twist. Outside of the main breeding season, which is roughly November to June, the adult males actually lead a mostly solitary life.
They leave.
They leave the massive hordes. They'll wander alone or in small, all-male bachelor groups. They become migratory.
Wait, if the alpha males are gone for half the year, how does the horde even function? Don't they need that central protection?
They rely on the collective strength of that huge female core. There's just safety in overwhelming numbers. The males only return to the horde during the mating peak, which is June to November, when the females are sexually receptive.
That seasonal get-together must lead to just astronomical levels of competition.
Exactly, and that brings us right back to the colors and the canines. This whole system ensures an extreme reproductive skew.
Meaning only the top dog gets to mate.
Pretty much. Genetic studies have confirmed that the alpha male, the one with the brightest red and the longest canines, can sire anywhere from 80 to 100% of all the offspring born in a season.
So that vibrant, volatile color isn't just for show. It is the key that unlocks almost all reproductive success. Okay, let's shift focus a bit. Let's look at the mandrill's actual life in the rainforest and the role it plays there. It's not just a colorful showpiece.
Not at all. It's a vital forest engineer. Mandrills are active during the day. They're semi-terrestrial. They have these strong forelimbs, and they walk with a sort of forward lean, which helps them move efficiently on the forest floor.
But they're still monkeys. They can climb, right?
Oh, absolutely. They are agile climbers, and they sleep in the trees every single night for safety. And these movements are significant. A horde can travel up to 15 kilometers in a single day.
That's a huge range. What are they eating on these long marches to fuel that kind of energy?
They're highly opportunistic omnivores. Their diet is incredibly varied, over 100 different plant species. It's mostly fruit, up to 90% when it's in season. But they'll also eat seeds, fungi, insects, even small vertebrates.
They must be incredibly efficient eaters to fuel a 50-kilogram body and keep a whole horde moving.
They are, and they have a great adaptation for it. Large cheek pouches, they can quickly stuff a huge amount of food in there while they're on the ground.
Right, where it's more dangerous.
Exactly. They can grab a stomach's worth of food and then retreat to a safer spot up in the canopy to actually eat it. It's a huge competitive advantage when you're foraging with hundreds of other hungry mouths.
But beyond just eating, what's their big ecological role? Why does the rainforest need them?
They are absolutely vital seed dispersers. Because of their size and strength, they're one of the few primates that can break open the hard shells of larger seeds. They swallow them whole, and then by moving 15 kilometers a day, they deposit those seeds far from the parent plant.
And they deposit them in nutrient-rich fecal clumps, I assume?
That's the one. And this process is essential for the forest's health, particularly for what are called pioneer species.
Rid of those.
Think of the corkwood or the umbrella tree. They are fast-growing trees that are the first to colonize clearings or disturbed areas. The mandrill's long-distance seed dispersal is vital for making sure those gaps in the forest regenerate quickly.
So, despite their strength, their intelligence, which the sources say is on par with great apes, and their importance to the ecosystem, they're listed as vulnerable. What's the main threat?
It comes down to two things: habitat loss and, unfortunately, heavy hunting pressure for bushmeat. Mandrills are uniquely vulnerable because of their size and that tendency to gather in huge, predictable groups.
It makes them an easy target.
A very efficient target for commercial hunters. They can kill entire sections of a horde in a single outing, and they often target those big, bright adult males first.
Because they provide the most meat. But that must have a devastating ripple effect on the social stability.
It is extremely destabilizing. You take out the alpha males, you disrupt that entire testosterone-driven social structure, the dominance hierarchy collapses, and the whole breeding season becomes less stable and less fertile. Right now, Gabon is considered the last major stronghold for the species.
So to summarize this deep dive then, the mandrill. It's the largest monkey in the world, not a baboon. It uses the very structure of its skin to create the bluest color in the mammal world. And its extreme horde society is what drives this colorful, volatile evolution.
It's a perfect illustration of how form follows social function, but in the fiercest way possible. Its amazing colors aren't an evolutionary fluke. They're a direct, testosterone-fueled result of its unique, hyper-competitive social structure.
It's a spectacular creature that has evolved a whole visual language just to survive in a society of over 1,000 individuals.
A true evolutionary masterpiece, and as we said, a forest engineer that's now under immense pressure. And that pressure poses a much bigger question. Given their critical role as seed dispersers, the decline of the mandrill isn't just the loss of a magnificent species, it's a fundamental disruption to the African rainforest's ability to regenerate itself. When a keystone creature like this starts to fade, you have to ask yourself, what other complex, unseen evolutionary pressures are shaping the lives of the most colorful, competitive creatures we know? And what are the true long-term costs of letting them disappear?